that it will fall in plus minus 1 standard deviation, because you know that observations which fall plus, that's 64, the probability is 0.64. So if I say 2 standard deviation, you will say 0.95 or 95%. Another concept. That's, so number of students within 1 standard deviation, within 2 standard deviation, within 3 standard, is this clear?
Yes.
Probability of an observation to fall plus minus 1 or plus minus 2, clear?
From 2 standard deviation to 2 standard deviation, 95. From 3 to 3, it should be 100, not 99.7.
It's never 100%. Okay?
Yes.
Because these extreme lines, if you have peak, then these lines does not meet the x-axis. It continues infinite.
Yes.
That's why we cannot have 100. Eh? Is that clear?
Yes. Cumulative area. It's with this or not?
Which cumulative variance?
Cumulative area for this for the distribution.
No, I have.
Cumulative area. It's written.
What I have told you,
It's in a,
is it clear?
yes, this one.
When it is clear, when you read it, it becomes more clear, it becomes
It's
easier.
not clear, doctor. Just they want a number without saying anything.
For example,
For example, here, doctor, they say that cumulative area near to 0 is equal minus 3.49. How can I know where they find this result?
time for the time. For the time.
Doctor,
Now I will tell you the third important. Yes.
from the first to second, it's 16%.
From which first second?
First ST to second.
First to second?
Yeah, it's 16.
From this side is 16, from this side is 16. So total SD, 2 SD contains 32%.
Because when I calculate, it's 13.5.
Yes, so when you go for 2 halves, these are 2 halves, 1 half
Yeah,
from
yeah.
this side.
From this side.
So you divide it by 2, no?
But when I divide 95 in the 2, it's equal 74.
Yes.
Or 47.
47, yes. If
This
I
mean-
say
this
between
mean-
2 and, so you will combine these two. You will combine this and this, you will get 47 point something. On this side,
yeah, yeah.
47 point something on this side.
But it's equal not 16, it's 13.5.
13.5, very good. So it's 13.5. So you are getting that thing. Right?
Yeah, yeah.
Now it's getting. Very good. I quickly put 16, but it's actually 13 point something. All right. Now another concept. So the distribution is clear? No confusion? So in 1 standard deviation plus minus, you have 68% of observations. If we are talking only mean and plus, 34, mean and minus, 34. In 2 standard deviation, 95% of the observations. And if I talk between 1 plus 1 standard, 2 standard, 13.5 on the right side as well as on the left side. If I talk total about 2 standard deviation, mean plus minus 2 standard deviation, 95% will be there. Is that clear? Now that was one point. Second, I talked about the probability of any value to fall within plus minus 1 standard deviation. You easily answered that question. Now I will ask you, I will tell you the third question. Third understanding. So the third understanding tells us, so till now we know about the observations which fall above and below the mean, 1, 2, 3, or whatever. We also talked about the probability of any observations to fall within 1 or within 2. The third thing is area. You must understand that the total area under this curve is always equal to 1. Total area is 1. All this area is equal to 1. So if I have a mean plus 1 standard deviation, what is the number of observations? Total number of observations in both? 68 is total. 34 is here, 34 is here. Is that clear? So if I say what is the percentage of area, it is 0.68. So this is the total area which is under 1 plus minus 1 standard deviation. So in under 2, it will be from here Here we have 95%. So 0.95 is the total area under the curve within 2 standard deviations. Very simple. Nothing logical about this. Nothing logical. Easy enough. Find difficulty? Hey, we don't have difficulty now. Is that clear?
Yes.
Good. So this was, as I said, these were the observations. The only thing is they changed it to SDs. Why they changed into SDs? For example, I have something which no side talks. For example, I am measuring the distance from here to my home in kilometers. This is one way, so this was kilometers. Now I am measuring this distance in miles. You know mile?
Yes.
Mile is also a measure of distance. So this is just change of units. Nothing more than that. There's nothing special about this. So we are changing this thing, what he called as z-scores. When we have these z-scores, we try to figure out that what is the 1 standard deviation, 2 standard deviation, what are the z-scores corresponding to these standard deviations. So what we are trying is the average distance of any value from the mean, average distance of any value from the mean, but this time the only thing is that it is standardized. Previously I was using kilometers, now I am using miles. That's it.
Clear.
Is that clear?
Clear.
So now where we should go? This is very important because I told you, because this will help us in further understanding. So this is everything about the normal distribution and standard normal distribution and what are the number of observations, everything you cleared in one go, simple. No difficulty? Or any difficulty?
No.
Easy. Easy?
Yes.
If there's any further difficulty, you can come to my office and we can discuss it at individual level. And better is that, first of all, if you have any difficulty, ask your friend what he was talking about. Was he talking sense or it was a rubbish thing? So ask him, discuss with him. Okay? Then come back to me and we can discuss again. So there's nothing to worry about. These are easy things. What I need your 100% brains here. Because this is mathematics, this is statistics. That's why I need you here. Okay, now I go to the second topic. So this topic is clear?
Yes.
This is everything which is written on those 64 slides. What is 64 or 48 slides?
46.
46. To be appropriate, to be exact, 48 slides. This is everything what was in these. Now what he tells you simple things. For example, he tells you that if for example, my student, please, if I have a mean of 25, and I have a standard deviation of 7 marks, for example, you take marks in the exams.
Okay.
Okay? So I have a mean and standard deviation given to you. Please tell me what is the interval in which 95% of the observations fall. I will ask you 2 questions. For example, tell me the interval in which 68% of the population falls, and tell me that the interval in which 95% falls. How will you do that? If you have understood what I was talking, then you can answer this thing. I have a standard deviation there, I have the mean there. How will you say that how much observations give the range of the numbers? What numbers will fall that we have 68% of students getting those marks? How will you do that?
Plus minus 7 in the first one.
So we have 25.
Yes.
So because it is only one standard deviation,
Yes.
plus and minus,
30.
and the standard deviation is 7.
Yes. 30.
So plus 30 will go minus 30.
Yes.
So it will be 32,
And 16.
16. So this
18,
is
18.
Oh, sorry. I'm missing plus 16, 8 in terms of 6. No? So it's 18 to 32.
Yes.
So that means 18, you are 68% of the students will get the mark between 18 and 32. Huh? What does it mean? So I made the normal distribution.
Yes.
Did I make it? I told you that the mean is this time,
Yes, 7. 25.
and the standard, this is one standard deviation. Plus, this is one standard deviation, minus. And this is two standard deviation, plus two standard deviation, minus. So this was 25.
Okay.
Now one standard deviation I will add. It tells me plus minus one standard deviation. Standard deviation I know. I will put the 7. So I will write plus 7 and minus 7. So when I put here one standard deviation, there will be 32 marks, and here it will be 18 marks. So because I know from the normal distribution that 68% observations are here.
Yes.
Now there's nothing good in it. Huh? It's very simple. Nothing good from my side. It's all good from your side. So in two standard deviation, what will happen? Now I said 2. I said 95%.
40.
So what's the mean?
25.
Plus 2 into standard deviation. Because I know 95% means 2 standard deviation. Plus and minus. So I will do 25 plus 2 into 7. So it will, what is this?
39.
I'm just opening it up for your understanding. So this is 39.
11.
And if I go the reverse way, minus, then I will write 25 minus. So this is one value, upper value. 25 minus 2 into 7. So it will be 11. So if I make the second observation, it will be between 11 and the 2 standard will be
39.
39. So your 95% of your observations will fall here. What's wrong?
Yes, clearly.
Oh no, you are looking on the sky, just counting the stars.
Clearly.
Is it?
Yeah.
So that is from there. So what I told you, what we have understood from this, it tells you that if you know the mean, if you know the standard deviation, you can construct the whole normal distribution.
Yes.
So the normal distribution is a function of mean and standard deviation. This is the bottom line. This is the bottom line. The key message is that the normal distribution is a function of mean and standard deviation. If you know it, then you can calculate it. You can draw that. I have drawn it.
Yes.
So I told you that what is now given mean, given standard deviation, what are the values of 1 plus minus 1 standard deviation? What are the value of the marks for 2 standard deviation? Is that clear?
Yes.
I can only ask for the 1/2 from mean to plus 1, but not minus 1. So that time you should know. 34% is only.
Okay.
Then you can calculate yourself. Right? Is that clear?
Yes.
These were also because the examples given, probably.
Yes.
So now you can calculate it.
But also, Doctor, there was an example that any difficult in this.
What was difficult now? You have understood, you should be able to do it. If there's anything more, you should use your brains now.
We use it, Doctor.
No, you're not using. You're keeping them safe for next year. I don't know why.
Can we, Doctor, do one together?
Which one?
The last
Then
one.
I will have to wait.
This
thought.
one, because there is this point I don't know from here.
So this is the same thing.
Let's do it.
The two standard deviations. Two standard deviations.
Yes.
If you go and see the tables, go and see the tables. You see the table? Table is given.
Yes, yes.
In the tables, what is written instead of I said 2?
Yeah.
Actually, it's not 2, it's 1.96. That's where from we got a figure. 2 standard deviation is equal to 1.96. So he is multiplying it by 1.96. So from here,
Don't need this, because this exercise.
so this you click. You got this one?
Okay, the two is not equal, 2 standard not equal to 2.
So it's not actually exactly. But once I use a 2, it means you use a 2, not 1.96. Okay?
Okay.
Let's go to the second point. Because if I stuck it there, then it will be very difficult for me to move ahead. Second thing, which I talked about, was hypothesis testing. You remember?
Yes.
I told you that there are two things. Whenever we carry out a research, we have something called as the alternate hypothesis, we have something called as the null hypothesis. We also said in either of these hypotheses, we either calculate the mean or we calculate the proportion.
Yes.
Then we also said about the signs which we use.
Yes.
I said, for example, if I am talking about an alternate hypothesis, I said it's equal to mu A. This is again an alternate hypothesis. Okay?
Yes.
Then I said that the signs which it uses, for example, it uses one of the sign like this. What is this sign?
No equal. More than.
More than. Simple. You have most of you have confusion. I don't know why about these signs. You should simply
more.
you should make a line. Okay?
Yes.
When I say more, so it should the arrow should go towards this. When I say less, so this is less, this is more. So when I use these signs, for example, this or this, you first make on the left side less, on the right side more, just put an arrow. So this means more, this means. Is that clear?
Yes.
So it's more than, for example, any value, 200. But this was about the
Alternative.
alternate, but what's this symbol?
Mu. Whole
Mu means?
population. Mean of whole population.
Mean. So we are talking about some quantitative variable,
Okay.
which you can measure.
Yes.
So what will be the null hypothesis for this?
Zero. Okay. Zero. No.
Ah, good.
And
Yeah.
Okay, then
More or equal. More or equal.
more or equal.
More or equal.
There is equal sign.
It's more or equal. So I can put it like this.
Yeah. Yes.
Okay. If I have now less, then what should I put?
Less or
Less or
equal.
equal.
Less or equal.
So this means actually when I put like this into 200, it means actually h0 is to mu0 is equal to 200. The same thing.
Yes.
Similarly, if this sign changes, I will change here. h0, mu0, it says less. I say again equal. Less or equal. It is same thing if I put equal sign. Is that clear?
No.
Huh?
It's not equal.
What?
It's less or equal.
Yeah. Less or equal. So this is more or equal.
Yeah.
So it doesn't matter now if I put a equal sign.
okay.
It doesn't
Yeah,
matter
yeah.
now. Is that clear?
Okay.
So these were the two things. There was third thing also which I told you. We said that if we have an alternate hypothesis HA, mu A, 200, it will tell me it is not 200. The other will be H0, mu0 is equal to 200.
Yes.
Yeah.
Is that clear?
Yeah.
So, not equal, more or less. They are signs of
Alternative hypothesis.
equal, less,
Null hypothesis.
equal, lesser equal, more or equal.
Null.
None. Is that clear?
Yes.
So you have no confusion with this.
Yep.
Good. Now, why is these signs important? This I will tell you. I told you in that lecture that what you do is you actually, whatever you want to support, any hypothesis, if you want to support that, you need to put that in alternate hypothesis.
Yes.
And then you need to construct a null hypothesis.
Yeah.
Did I told you?
Yes.
Then I told you that on this null hypothesis you will collect the data and see what are the chances of getting this data, this value. For example, this was mu A. Now I will not write HA. You know,
Yes.
A, if it is more than 200, so mu0 says it is
More or equal.
equal to. Now, instead of 200, if I got 110,
Okay.
so then what I do, so once I collect the data on this, then I applied some test. Isn't it?
Yeah.
Applied some test, which I did not show you yet. What test I applied. I'll show you now in this section. So till now, two things were clear to you. Number one, we have an alternate hypothesis. There are different signs for that. We have a null hypothesis. There are different signs for that. And when we check or when we test this hypothesis, we test the null hypothesis.
Yes.
And then what do? So when we get a data on the null hypothesis, that is mu is equal to 200, we get a data on this. This data will help us to either reject this or fail to reject this. Because there were only two things which you can do. When we rejected this, we accepted the alternate hypothesis. That was telling us it's more than 200. We accepted this. But when we failed to reject this, we did nothing.
We shall.
Is that clear? That's what we talked earlier. About the judge and the person who is involved in that, and then we calculate the data. I don't want to repeat all these things. The simple thing is that we have an alternate hypothesis, then we generated a null hypothesis. I brought the data, collected the data on null hypothesis, then I tested my null hypothesis which I created, and this helped me to either reject my null hypothesis which I created, or I will fail to reject. If I reject my own null hypothesis, that means the other hypothesis is true. But if I fail to do so, I cannot say anything about neither the null nor the alternate. Is that clear?
If you have a hypothesis, for example, it doesn't matter which type is it, it's null or is it alternative?
What?
You have a hypothesis.
So once you read that hypothesis, it will tell you whether it's an alternate or null.
Yes, okay. Neglect the type of it. I have to reject it using alternative only, using
Null.
always.
Always.
Even if you have null.
So once you have the null, you will construct an alternate and put that alternate there
Okay.
and work on that null.
Okay.
Because you are always you are testing the null. You are not testing the alternate because that's not yours.
And what about, doctor, when the result will be near to the
Who will tell you? I have not gone to that point. I have not gone to that point. Now I told you something about the normal distribution, and I told you on that day this will be helpful for us to understand. Now why does it come again? It's coming on your head again and again, this null hypothesis, or this normal distribution. So I said it's mean, I said it's 1 standard deviation on either sides, I said it's 2 standard deviation, I said 95% of the observations are here. We told it, no? Now, once I am working with the hypothesis testing, there are 2 ways to test it. How many ways?
2.
One way is called as a traditional method. I will tell you how we do it, but you should first know the methods.
Okay.
One is called, another is called a p-value method. P-value. So what are the methods? Traditional method and a p-value method. Is that clear? When we test by these 2. But in traditional method, I'll come to the traditional method. We say it is a left tail test. I say it is a right tail test. I say it's a 2-tail test. Now what is this? Traditional method, you have a left tail test. In traditional method, you have a right tail test. In traditional method, you have 2-tail test. Huh? Although you don't have any one of that. Huh? So what's that? So in traditional method, what we do? 3 things. Either I do left tail test, or I do right tail test, or I do 2. So what is the tail? Tail is here in the normal distribution.
Yes. Okay.
So either I do this side test, or I should this side test, or I do on the both sides. Is that clear?
Yes.
But how? How we determine that? The question is how we determine that which tail we have to test. How we do that? Any idea? If you tell me, anybody tells, I will give 10 reals. Whether I should go for a left tail, right tail.
Whether the tail is positive or negative.
Yes.
After
So how can I decide it?
Where the tail point, doctor?
Wherever the tail point is, forget it. I am telling you, I have tested a hypothesis. Okay? I am telling you, I will go for a left tail test.
Negative.
Or I am telling you, I will go a right tail test.
Positive.
Or I am telling you, I will go for both. tails.
Negative 100.
Now, which thing will tell me where I should go?
Mean.
Mean.
Yes. Mean.
About this observation.
Right?
Yes.
Use the grey matter. Huh? You have kept it stored and don't use it. Use it. I have told you long time back.
The consideration, the mean, Doctor. Then the tail, where is
The median.
Median.
Right to the median or left?
Tendency.
So then none of you deserve yes. Which tail?
I'm Steve.
You are still, you don't have tails. Huh? Yes. Now see, I told you one important thing, I give you a pointer, but you missed that. I told you we have a hypothesis test. Hypothesis, an alternate hypothesis. It tells you equal to mu A is either more, either less, or is not equal. So if it is more, I am going for a right side test. If it is less, I am going for a left side test. If it is not equal, that is either side. So I have given you that idea, which will tell us which test I should perform in the traditional method. Should I go for the right tail test? Should I go for the left tail test? Or should I test this hypothesis on both the tails? It is determined by the alternate hypothesis. Is there anything special? Now, that is why I gave you an idea earlier that if it is like this, you are forgetting it, put an arrow.
More than.
Put an arrow. So when I put an arrow, I was pointing you that when I will be testing this hypothesis, when I will be testing my null hypothesis with this type of hypothesis, I will be doing a right tail test. If I will be testing my null hypothesis with this alternate hypothesis, I will be doing a left tail test. If I am testing my null hypothesis against this hypothesis, I will be doing tests on both sides.
First one right or
Right.
Oh, come here, come forward. What is this? There is arrow. Is it towards the right or left? So check here. So it's right. If I say this thing is right or left, so it will left tail test. When I use this one, that will both. So I told you in the two standard deviation of 95%. That means if my whatever value I get from the null hypothesis, if I am doing a left tail test, now I'll tell you, I'll show you. If I am going for a left tail test, so I will construct this. Okay? This is mean. This is 1 SD, 1 SD. This is 2 SD. This is 2 SD. Okay? When I say left sided test, I have to tell you how much confident I should be in order to perform this test. And in your research proposals, all of you have written that I will be 95% confident about the results. Isn't it? Yes. That means you are confident about 95%. So when I say 95%, I know that within two standard deviations, the 95% lies within the two standard deviations.
Yes.
Is that correct?
Yes.
So this will be the 95% here. So then I told you again that if I get that value in the null hypothesis, a value, I may reject the null hypothesis or I may fail to reject. Now how I am doing that? From that value, I am constructing something called as the critical value. From that, I am trying to get a critical value. Then on this critical value, I will see that the value which I have got from the null hypothesis, whether it falls here or it falls here. This area will be a non-rejection area, this will be a rejection area. If my results of the null hypothesis fall here, I will reject that null hypothesis. If it falls here, then I will fail to reject. How does it work? I will tell you. So this is called a left tail test. Similarly, I will do a right tail test. That means 5% of the observations are here, 95% are here. In the second test, the right tail test, I will do the same thing, but this time it will be on the right side. that rejection, this is called non-rejection region, this is called rejection region. Okay? If I say both sides, I am going like this. This is non-rejection region, this is rejection region, this is rejection region. If my value falls anywhere here, I will reject it, the null hypothesis. If it falls here, I will reject the null hypothesis. If it falls here, I will reject the null hypothesis. But if it falls here, here, or here, I will fail to reject. That's left-sided, right-sided, or a two-tailed test. Now let's go back and open our presentation.
Doctor, you say you never test alternative.
Alternatives, but that using the direction where I have to test my null, on the right side or left side or both sides. So let us start our discussion. Is that clear?
Yes.
So traditional method helps us. So we have traditional method of testing hypothesis. We have a p-value. In traditional method, we have either left side or right side or a two-tailed. It is determined, which tells us which way to go. It's given by the alternate hypothesis, the direction of the alternate hypothesis. Now let's go to first. So this was all the things that we have a mean plus standard deviation minus standard deviation. This is 1 and this is 2 and this is 3, everything gone.
Yeah.